This is a quick video on scientific notation and conversion factors. Okay, to convert a number in a scientific notation, you need to move the decimal to the left or to the right. We move the decimal left or to the right in order to get the decimal into the first position. Let's take a look at this number here, the number 156000. Now the rule is we're going to move this decimal point until it gets to the first position, and we'll count how many places we move it. That's 1, 2, 3, 4, 5 in order to get into the first position. We will not include any zeros that are not considered significant. So these are placeholder zeros. We're assuming the decimal was recorded there just to move it. So I'm moving it 1, 2, 3, 4, 5 spaces. So I'll write it as 1.56 times 10 to the fifth. Now, if you're moving the decimal point to the left, the decimal point going to the left means the exponent will get larger. So we moved it to the left 5 spaces. Therefore, it went from 0 up to 5. Now, what if we move the decimal to the right? So this number here, we want to get the decimal all the way to the ones place, which is right there. Let's count how many times we go. 1, 2, 3, 4, 5, 6. So 5.3 times 10. Now we'll make it to the minus 6 because we're moving the decimal to the right. The exponent goes down. So let's just try one more example. Let's say I have the number 150. Remember, the decimal point is going to be here. We don't normally write it. But let me count how many spaces I move that. I move it 1, 2 over. So this number is 1.5 times 10 to the second. Notice how I do not include this 0 here because it's a placeholder 0 only. By scientific notation rules, you do not keep non-significant zeros. One more example. Let's do 0.0030. So I'm going to move this 1, 2, 3 decimal points to the right. I'm going to put that decimal as 3. Now I'm going to keep that 0 at the end of the number because it was significant. So 3.0 times 10 to the minus 3. And that's how we do scientific notation. Always move your decimal point to the first or the ones position. You keep significant zeros in your answer. So that's how it works. All right, now it's time to look at converting factors. So this is when we take one unit and convert it into another. Let's start with the bottom one here. 15.3 quarts, okay, equals how many gallons? Well, here we have to build some ideas here, okay. I do know there are 4 quarts, and I'll just label it like this, okay, equals 1 gallon. And I'll label it GAL for short, okay. So I prefer to call this the bridge method. I'm going to make a cliff on this side. I'm going to put 15.3 and I'll label that as quarts, QT. And on the other side, I'm going to say equals, and there is another cliff here, and gallons. Now here's my bridge piece, my equality here. And what I'm going to do is I'm going to fill in the middle here. Okay, and this is going to be a one-stepper. I can tell because there's a direct relationship between quarts and gallons. Now, I want gallons on top over here. So that's what my final answer is going to be. So I'm going to take this and I'll write 1 gallon on top. And I'll put 4 quarts on the bottom. Whatever unit is on the top here will go on the bottom here. So I'm going to put the number 4 quarts on the bottom and 1 gallon on top. So what that's going to do then is it will cross off our quarts. And then I'll just take 14 or 15.3 divided by 4 to get my gallons. And that answer is 3.8. Okay, I'm trying to keep reasonable significant digits here. Not too worried about it for this example. Okay, so 4 actually has an infinite number of significant digits in it because 4 is exactly equal to 1 gallon. Okay, so that's a conversion factor there. The next one, 25.5 meters per second into kilometers per hour. Now there's 2 bridge pieces there. Let me write them here. Okay, I know that in 1 kilometer, there's 1,000 meters. And 1 hour, there is 3,600 seconds. So I know this one has to be a two-stepper because there are 2 conversion factors that I have there. So let me draw my bridge piece over here, my cliff, and I'm going to put 25.5, and I'll have meter and then seconds here on the bottom. On the right side here, and I'll give myself plenty of room, I'll draw my equal sign. What are we going to? We're going to kilometers per hour. Okay, now I need to arrange my pieces. I'm going to do a two-step bridge here. I'm going to times and a line and a times and a line. Okay, because I got to convert both things. Let me convert the meters and the kilometers first. So I look over here. Kilometers is on the top over here, so I need to have the 1 kilometer on top here. Okay, and meter is on the top here. I need it to go to the bottom here, so 1,000 meters. So what's on the top here needs to be on the bottom there. What's on the top here needs to be on top. All right, now let's continue. I've got seconds on the bottom here. It needs to be on top here. So 3,600 seconds. And then hours on the bottom over here. So I write 1 hour over here. So note, these units have to occur exactly. Whatever's on top must be on top here. Whatever's on the bottom must be on the bottom here. These have to be opposites. This one's on top, therefore it's on the bottom. This one's on the bottom, this one's on top. Now why does it have to be so? Well, the reason is we need to cancel out these units. The seconds needs to cancel here, and the meters need to cancel here. Now we're left with kilometer per hour, which is what we want on the right side. So now we're going to take 25.5 divided by 1,000, because that's on the bottom, and times 1, times 3,600 divided by 1 equals. Now you don't need to really do the ones if you don't want to, but the answer then is 91.8, and that's going to be kilometers per hour. And that's how we handle conversion factors. There's 3-steppers and 4-steppers. All depends on how many equalities you actually need to do. Typically in chemistry, we do 1, 2, and 3-steppers. Okay, that's it for our lesson for today.